Hello viewers, welcome back to our channel. So today we're going to talk about subtraction of numbers in standard form. Subtraction of numbers in standard form. Before we proceed, let's quickly recall that standard form is a way of expressing a very large number in a simpler manner. And we have a way of expressing a number in standard form. And for you to express a number in standard form, we say a, which is the coefficient, times 10 raised to power n, is a way of expressing a number in standard form. And if you want to express a number in standard form, your coefficient, which is your a, should be should be less than or equal to 1 or less than 10. Should be less than or equal to 1 or or less than 10. It should not be more than 10. So that's how to express a number in standard form. And now let's take these examples. So question 1 says evaluate 15 times 10 raised to power 4 minus 5.1 times 10 raised to power 4. Now, we have several methods in which we can use to solve this particular question. And in today's class, I'm going to apply two methods to solve this question. So let's start with the first method. For the first method, all you need to do is to change this number in standard form to an ordinary number. You change those numbers in standard form to an ordinary number by expanding them. So we have 15 times 10 raised to power 4 means tens of 1,000 minus 5.1 times tens of 1,000. So 15 times 10,000 will give us 150,000 minus. So if we multiply this 10,000 by this 5.1, we're going to be having 51000. You move this 1, 2, 3, and 4. So we have this empty space we fill up with with your 0. Now all we need to do is to subtract. So we have 150,000 minus 51,000. So let's subtract. We have 0, 0. 0 cannot minus 1. So you borrow 1 from this 5. So we have 10. This is 9. This one has changed to 4. 14 minus 5 is going to give us 9. So if you take a look at this number now, you will see that this number is not in standard form. So now let's express this number in standard form by moving our decimal point to the last digit, which is 9 here. So we move 1, 2, 3, 4. So we have 9.9 times 10 raised to power 4. You are going to be having a positive 4 if you are moving your decimal point to the left, and you're going to have a negative 4 if you are moving your decimal point to the right. So this is our number in standard form. So let's take the second method. So for the second method, we have 15 times 10 raised to power 4 minus 5.1 times 10 raised to power 4. So in this case now, we take a look at the common factor, and the common factor here is 10 raised to power 4. So we subtract 15 minus 5.1 times 10 raised to power 4. So we can balance this up with 0. 0 minus 1 is not possible. You can borrow from this place. This is 9. So we have 14 left. 14 minus 5 will give us 9. So therefore we have 9.9 times 10 raised to power 4, which is still the same thing as the answer we have here. Alright, so let's take the second example. The second example says subtract 5 times 10 raised to power minus 4 minus 4 times 10 raised to power minus 4. Now if you take a look at this second question, we're having a negative exponent. So how are we going to go about this? Let's use the first method by changing those numbers to an ordinary number. So we have 5 times 1 over 10 raised to power 4. So you can express 10 raised to power minus 4 as 1 over 10 raised to power 4. You recall your indices rule. So we have minus 4 times 1 over 10 raised to power 4. So we have 5 times 1 over 10 raised to power 4 is is 10,000 minus 4 times 1 over another 10,000. So this has changed to a fraction. So in this case now, we can solve by finding the LCM of this question, of this subtraction of fraction given here, or we change our number to an ordinary number completely, then we can evaluate it. So we have 0.0005 minus 0.0004. So now let's subtract. We have 0.005 minus 0.0004. So this is 1, 0, 0, 0.0. So we can express this number now in standard form by what? By saying 1, 2, 3, 4. Now don't forget, I told you that if you are moving your decimal number to the right, your exponential, your integer is going to be what? Negative. So we have 1 times 10 raised to the power what? Minus 4, because we move our decimal point 4 times 1, 2, 3, and 4. So this is our final answer. Now let's use the second method to figure out this what? The answer to this question. So we have 5 times 10 raised to the power minus 4 minus 4 times 10 raised to the power what? Minus 4. Now the common factor we have here is what? 10 raised to the power what? Minus 4. So we are going to subtract them completely. We have 5 minus 4 times 10 raised to the power what? Minus 4. This is 1 times 10 raised to the power what? Minus 4, which is still the same thing as the answer we are having here. So that is that for second question. Let's move to question 3. Now let's evaluate the third question. So we have 136000. This number is an ordinary number, not a standard form number. So we have minus 40 times 1000. So we can have 136000 minus 40 times 1000 will give us what? 40,000. So let's subtract 40,000 from 136000. So we have 40. Let's subtract. This is 0, 0, 0, 6. 3 cannot minus what? 4 is impossible. So we have what? 9 here. So this number is not in standard form. Now let's express this number in standard form by moving our decimal point to the what? To the right, making the first number, which is the coefficient, to be what? Less than 10. So we have 1, 2, 3, 4. So this will be 9.6 times 10 raised to the power what? Power 4 is our final answer. Let's use the second method to figure out the same answer. Minus 40 times 10 raised to the power what? Power 3. So in this case now, I will need to change this ordinary number to a standard form number so that they can have common factor and we can evaluate completely. So we have 136 times 10 raised to the power what? Power 3 minus 40 times 10 raised to the power what? Power 3. Now they are having the same exponent and base, so we have 136 minus 40 times 10 raised to the power what? Power 3. So let's subtract. This is 6. 3 cannot minus this. This will give us what? 9. So we're going to be having 96 times 10 raised to the power what? Power 3. Now take a look at this number. It's not yet in what? In standard form, because this 96 is greater than what? Than 10. So let's make the number to be what? Less than 10. So we have 9.6 times 10 raised to the power what? Power 1 times 10 raised to the power 3. So we have 9.6 times 10 raised to the power 1 plus 3. We need to adopt our what? Our multiplication rule in indices. So this one will give us. So this will give us 9.6 times 10 raised to the power 4, which is still the same thing as the answer we have here. So for the fourth question, we have 30 times 10 raised to the power minus 3. We can express it as 1 over 10 raised to the power 3 minus 4 times 1 over 10 raised to the power what? Power 4. So let's express this number in an ordinary form, or we expand it. So we have 30 over 1000 minus 4 over 10,000. So if I want to express this now in standard form, I'm going to be having 0.03 minus 0.0004. Now I can subtract now. I will be having 0.03 minus 0.0004. Let's balance this up with what? With 0. We borrow 1 from this 3 to this other side. So we have, this is 6, this will be 9, this is 2, 0.0. Now let's express this number in standard form by moving our decimal point to the right. This will be 1, 2. So we're going to be having 2.96 times 10 raised to the power what? Power minus 2. That's going to be our final answer. So now let's use the second method to figure out the answer for this same question. So we have 30 times 10 raised power minus 3 minus 4 times 10 raised power minus 4. So to solve this question now, all we need to do is to adjust either of these exponents to be the same as this or this to be the same as this so that we can evaluate completely. So let's adjust the exponents. So we have 30 times 10 raised power minus 3 minus, we have 0.4 times 10 raised power 1 times 10 raised power minus 4. So I'll be having 30 times 10 raised power minus 3 minus 0.4 times 10 raised power 1 plus minus 4. So this will be 30 times 10 raised power minus 3 minus 0.4 times 10 raised power minus 3. Now I'm having the same what? Base and exponent now. So I can evaluate completely. So we have 30 minus 0.4. We can balance this up with 0 times the common factor 10 raised power minus 3. So let's subtract. 0 cannot minus 4 is impossible. So we borrow from this 3. This one will change to 2. This is 6.92 times 10 raised power what? Minus 3. Now if you take a look at this number now, 29.6 times 10 raised power what? Minus 3 is not yet in standard form. So let's express this number in standard form. So we're going to be having 2.9 times 10 raised power 1 times 10 raised power minus 3. So let's apply our multiplication rule in indices. So we have 2.9 times 10 raised power 1 plus minus 3. This will give us 2.9 times 10 raised power minus 2. And that will be our final answer, which is still the same thing as the answer we have here. So now let's solve the next question. We have 0.045 times 10 raised power 4 is 10,000 minus 35 times 1 over 100. So now let's multiply this by 10,000. So we're going to have 1, 2, 3, 4. So our number is going to be 450 minus 35 over 100. So 450 minus 35 over 100. That's going to be 1, 2. So we're going to be having 0.35. So let's subtract 0.35 from 450. So we have 450 minus 0.35. Let's balance this up with 0. 0 cannot minus 5. So let's borrow from this 5. 1, 1, 1. This has changed to 9. 9. So we have 10 minus 5 is what? 5. 9 minus 3, that will give us 6.944. So if you take a look at this number now, it's not yet in standard form. So let's express this number in standard form by making the first number, which is the coefficient, to be less than or equal to 1 or less than 10. So let's express this 1, 2. So this will be 4.4965 times 10 raised power what? Power 2. Because we are moving our decimal points to the what? To the left. That will be positive. If it is right, that will be what? Negative. So this is our final answer for this. Let's use the second method and see what we're going to get for this same question. So we have 0.045 times 10 raised power 4 minus 35 times 10 raised power what? Minus 2. So in this case now, all we need to do is to make sure that the base and the exponents are the same. So either way, either this is the same as this or this is the same as this. But for easy understanding, let's change our exponent to minus 2. Let's change our exponent to what? To be minus 2. Now, let's consider this number. We need to subtract the number from this 4. And we're going to have what? Minus 2. That's 4 minus 6. 4 minus 6 is going to give us what? Minus 2. So let's adjust the number. We have 1, 2, 3, 4, 5, and 6. So our number is going to be 4, 5, 0, 0, 0 times 10 raised power minus 6, because we are moving our decimal number to the right, times 10 raised power 4 minus 35 times 10 raised power minus 2. So now we have adjusted our number to be having an exponent of what? Of minus 6. So we need to what? Apply our indices rule here so that we can have the same exponent as the second number given to us. So we have 45000 times 10 raised to power minus 6. Let's apply our indices rule, that is multiplication rule. So multiplication rule now, we're going to be having plus 4 minus 35 times 10 raised to power what? Minus 2. So we have 45000 times 10 raised to power minus 6 plus 4 will give us what? Minus 2 minus 35 times 10 raised to power what? Minus 2. Now we are having the same what? We are having a common factor, which is what? Base 10 raised to power what? Minus 2. So we have 45000 minus 35 times the common factor 10 raised to power minus 2. So let's subtract. Now, in this case now, 0 cannot minus 5, is not possible. So we borrow 1 from this 5. 1, 1, 1. This has changed to 9. This is 9. This is 4. This has changed to 4. So we're going to be having 10 minus 5. That will give us what? 5. 9 minus 3. That's going to give me what? 6. And 9. We have 4. We have our 4 times 10 raised to power what? Minus 2. This number is not yet in what? In standard form. So let's express it in what? In standard form, so that the coefficient, which is the first number, will be less than or equal to 1 or less than 10. So we adjust our decimal point. So we have 1, 2, 3, and 4. So this will be 4.4965 times 10 raised to power what? How many times did we move our decimal point? We move it 4 times, and it is what? Left hand side. So it will be positive times 10 raised to power what? Minus 2. So we have 4.4965 times 10 raised to power 4. We apply the indices rule, multiplication rule. 10 raised to power 4 plus minus 2. So this will be 4.4965 times 10 raised to power 2, which is the same thing as the number we are having here. So this is how to go about this question on standard form, subtraction of standard form without using what? Calculator. So let's move to the last question we have here. In this case, we are having different exponents, positive and negative. So let's solve this. We have 1360 times 10 raised to power minus 2 can be expressed as what? 1 over 100 minus 0.004 times 10 raised to power 3, that is 1000. So we have 1360 divided by what? By 100 minus 0.004 times 1000. If we multiply this by 1000, now we're going to be having 1, 2, 3. This will give us 4. Therefore, we're going to be having 1360 divided by 100 minus 4. So let's adjust this. Let's divide it by what? By 100. We're going to be having 1, 2. So this will give us 13.6 minus 4. So let's subtract. Let's subtract 13.6 minus what? Minus 4.0. This is 6. 3 cannot minus 4. So we say 13 minus 4 is going to give us what? 9. So we have 9.6. 9.6 times 10 raised to power what? In this case, you can see that our number is already in standard form and without any what? Any exponent. So if you encounter any question of this kind, all you need to do is to say 9.6 times 10 raised to power what? 0. Because anything raised to power 0, recall that 10 raised to power 0 is always what? 1, which will still give you this what? This same number 9.6 back. So our final answer is going to be what? 9.6 times 10 raised to power what? 0, which is going to give us this same number. Now let's use the second method to see what we're going to get if we're going to get the same answer as the first one. So let's go. We have 1360 times 10 raised to power minus 2 minus 0.004 times 10 raised to power what? Power 3. So in this case now, all we need to do is to adjust our base and exponent to be the same as maybe minus 2 or minus 3, either of the two. But let's make our exponent to be what? Raised to power minus 3. Because if we change this one now, it's going to be longer than the other one. So we change this one now to be having an exponent of 3 as well. So that we're going to be having a common factor of what? Times 10 raised to power 3. Now let's adjust this number. We're going to be having 1, 2, 3, 4, and 5. So this will be 0.0136 times 10 raised power 5 times 10 raised power what? Minus 2. Because if I still multiply this same number by hundreds of thousands, I'll be having my number back. I'll be having this number back. So we have minus 0.004 times 10 raised power what? Power 3. So let's adjust this. We have 0.0136 times 10 raised power 5 plus minus 2 minus 0.004 times 10 raised power what? Power 3. So if we have applied our indices rule here, so we have 0.0136 times 10 raised power 3 minus 0.004 times 10 raised power what? Power 3. Now we've adjusted the what? The exponent to be the same. So we're having common factor here, which is 10 raised power what? Power 3. So let's subtract. We're going to be having 0.0136 minus 0.004 times 10 raised power what? Power 3, which is the common factor. So let's subtract. 6 minus nothing is 6. 3 minus 4 is not possible, so we have 13 minus 4. That will give us 9. 0, 0, 0.0. So this number is not yet in standard form. So let's express it in what? In standard form by adjusting our decimal point. So we have 1, 2, and 3. Don't forget, I told you if you are moving a decimal point to the right, it will be negative. And if we are moving it to the left, it will be what? Positive. So we're going to be having 9.6 times 10 raised power minus 3 times 10 raised power 3. So let's adjust this number now. We have 9.6 times 10 raised power minus 3 plus 3. That is, according to the what? Indices rule, the multiplication will change to plus. So we're going to be having 9.6 times 10 raised power minus 3 plus 3 will give you what? 0. So we have 9.6 times 10 raised power what? Power 0, which is still the same thing as the answer we have here. So friends, if you find this content useful, please don't forget to subscribe to our YouTube channel and hit the notification button so as to receive every new video we're going to be dropping on this channel.